In this lesson I'm going to talk about injective functions, or one-to-one functions as they're sometimes called. And the best way of all to explain these is to start off with an example of a function. And the example I've chosen here is the function x is mapped onto 2 to the power of x. Now what we're going to do is describe the function in 4 different ways, and then I will show how to test the function and see if it's injective in each of those cases. So the standard way, I suppose, of representing any function is to draw a table and the corresponding graph. And we see here we get values of x, for example, -2, -1, 0, and plot the corresponding values for y on a table. And then you take your points, -2 quarter, -1 half, 0, 1, and so on, plot them on the graph, and you get to see the shape of the graph here. So this is the graph of 2 to the power of x. Now we can show the exact same information in another way. We can take our values from the table and we can show a diagram as so. So again, it's the graph is 2 to the power of x, so we have our x values here in the domain and our y values in the codomain. For example, 2 to the power of -2 is a quarter, 2 to the power of -1 maps onto a half, and so we've got the same values again, just shown in a different way as a mapping. And a third way, I suppose, is just algebra. We can write it as y equals 2 to the power of x, or fx equals 2 to the power of x. And the fourth way of showing this is as a set of couples. Again, same information, just shown in a slightly different way. The function is given as -2 a quarter, -1 a half, 0 is mapped onto 1, 1 is mapped onto 2, and so on. Now that we know the 4 different ways of showing that function, let's look at how we test if it's injective or not in each case. So injective means the simplest way to think of injective is if there is at most one arrow arriving at each point in the codomain. So just like here, you can see if there's at most, so that means at most one arrow means 1 or 0 arrows. So 1 arrow or no arrow arriving. It's all about what's arriving in the codomain. That's how you know if it's injective or not. Or an English way, I suppose, in English the way we could say this is, it's like if you think of the domain as a question and the codomain as an answer. Every question has an answer, but every answer doesn't necessarily have a question. Here are 2 answers here which don't have a question corresponding to them. If we go back now to the function we had, keeping that definition in our heads, that injective means there's at most 1 arrow arriving at each point. We see that our graph for 2 to the power of x fits this, because we can see that if we go down to the actual diagram, there is at most 1 arrow arriving at each point in the domain, so therefore that function 2 to the power of x is definitely injective. So there's either 1 arrow or no arrows arriving at each point. Another way that you can test for injective, if you're given the graph instead of being given the diagram, you can do what's called the horizontal line test, and that involves drawing a horizontal line through the graph and seeing how many times that horizontal line cuts the graph. If it cuts it once at most in any place, we say that it's injective also. So it's another way of saying the same thing. So here we see a horizontal line cuts the graph once here, it cuts it once here, it doesn't cut it at all here, but this is okay, this is allowed as well, because as we said, as long as it cuts at most once. And again, if we have our function represented as a set of couples like here, we can also say the same information in this way. If the second part of the couple, if the y coordinate in the couple, if the same y coordinate appears more than once, that's the same thing as more than 1 arrow arriving at a point in the codomain. So that means it's not injective if that happens. Another way we can test for injective is as follows, and if you use this notation, if A is a point in the domain, well, FA is its image in the codomain, B is the point, again, FB is its image in the codomain. If FA happens to be equal to FB, like down here, if the two images are equal, well then, as you can see in the diagram as it stands, it's not injective because there's two arrows arriving, so we've got to fix that. So if these two are indeed equal, well, the only way we can fix that is by making these two equal at the same point as well, so that there is no longer two arrows arriving at the point, but one arrow. And we use that very often when we're given a function in algebra notation, as opposed to being given a graph or a diagram. So, so this is the test. Again, if FA equals FB, well then A must be equal to B for the function to be injective. And I have an example done out here. For example, test if that function x mapped onto 2x, the one we've just been discussing, if it's injective, but this time we don't have the graph or a diagram to help us. So we can still use this new method. Write down what the function is. Fx equals 2 to the power of x. So that means that some value of a in the domain, the f of a is 2 to the power of a, or the f of b of some other value b is 2 to the power of b. Now we put fa equal to fb, and if fa equals fb, that means that 2 to the power of a must be 2 to the power of b. If the 2's are the same, that means the powers must be the same, so the powers are equal, so a equals b. And that's our test for injective, because just to remind ourselves again, if fa equals fb, then a must be equal to b for the function to be injective, and we have just proved that a is indeed equal to b. Of course, that won't always work out for us. Here's an example, example 2, where the function is not injective. X mapped onto x squared. Again, take fx equals x squared, so some value a in the domain, the f of a is going to be a squared, the f of some value b is going to be b squared. If we put fa equals to fb, that means that both of those answers are equal, a squared equals b squared. Now be a little bit careful here. To get a, you've got to get square root of both sides. But when you get square root over here, and this is already squared, we get a plus or minus. Just to remind you the reason for that, if you had x squared equals 9, for example, the proper answer for x is plus or minus 3, because both of those answers squared will give you plus 9. So you see, here's a case where fa is equal to fb, but it doesn't necessarily follow that a is equal to b. Therefore, it's not injective. Now, sometimes a function can start off not being injective like this one we've just done, x mapped onto x squared, but we can make it injective by changing the domain or the range or both. And we can see that in the next example. So here's the function x mapped onto x squared. If we do the simple horizontal line test, we see it cuts sometimes in two places, so straight away that rules it out for being injective. And however, if we restrict the domain, here's the domain here, the domain, the x values, so that we only allow plus real numbers. So we change the domain from r to r plus, and that's the only change, nothing else. Well, then it becomes injective, because if you draw the graph now, we are not allowed have any negative. We are not allowed to have any negative x values, so the domain, which is the x values, cannot be negative. So we've crossed out all this region here. So we're only allowed to have this part of the graph. Now, if you do the horizontal line test, the horizontal line only ever cuts once or 0 times down here. But that's okay, because 0 or once, or at most once, is the test for injective.